Okay, today we're going to talk about reference angles. So the very top part is kind of review. It wants you to determine the sign of each trig functions in all four quadrants. So this is where y'all did add sugar to coffee. So all students take calculus. And as long as you understand that, you don't have to list them all out. These notes are for you. So if it helps you to write it all out, sine is positive, cosine is positive, and go through each trig function, then go ahead and do that. But if you know what this means, all functions are positive, sine and cosecant are positive in this quadrant, tangent and cotangent and so on, then I wouldn't write it all down. Okay. So, number one says determine if the values of the function are positive, negative, or zero. The only way it would be zero is if, like we talked about yesterday, if it's actually on an axis. So, like, if it was on this positive x-axis, the point is, 1, 0, right? So that's what it's talking about whenever it's talking about zero. So if you want to go ahead and label those, the positive y-axis, that point is 0, 1. Then it goes to negative 1, 0, and 0, negative 1. Okay. And that's what we talked about yesterday. So let's go through A, B, and C. Part A wants you to find the sine of 226 degrees. It wants to know is this positive, negative, or zero. So 226 degrees, let's see, this is 180, and this would be 270. So it's going to be in between those two degree measures. So it's going to be in quadrant 3, right? So in quadrant 3 is sine positive, negative, or zero. That would be negative. Okay, part B, 5 pi over 3. If you're not sure what quadrant that is in, what I do is I put 5/3 in the calculator and get a decimal. So that would be, 1.67 pi. So it's going to be past 1. 270 degrees is 3 pi over 2, which is 1.5. So it's going to be past that. So we're talking about quadrant 4. So if it helps you to have the decimal, you can do that. If you know 5/3 is greater than 3/2 and it's in quadrant 4, then go for it. But we're talking about quadrant 4. And it wants to know is cosine positive, negative, or zero in quadrant 4. And it is positive. The last one, cosine of pi over 2. Pi over 2 is 90 degrees. So we're talking about this positive y-axis here. So at this point, would your cosine be positive, negative, or zero? Okay, and your cosine is x over r, right? So 0 over 1 is 0. And we talked about that yesterday, if you need to review that video. All right, so our main topic today is reference angles. So a reference angle is the smallest positive acute angle determined by the x-axis and the terminal side of theta. Okay, so it's wherever that terminal side ends up, it's how far away from the x-axis it is. That's what the reference angle is. So the first one, if you have an angle in the first quadrant, okay, your initial side is always on this x-axis, right? So let's say we end up in the first quadrant, wherever, it doesn't matter. We want to find the distance from this terminal side to the x-axis. Whatever x-axis is closest. And here the closest one is the positive, not the negative side. Okay. If we're looking at an angle that ends up in quadrant 2, the closest x-axis for this one would be this negative x-axis. So your reference angle would be from this terminal side to the x-axis. And then quadrant 3, we start here and go all the way to quadrant 3, anywhere in quadrant 3, the closest x-axis would be the negative one. That would be your reference angle. In quadrant 4, the closest x-axis for quadrant 4 would be the positive one. So that would be your reference angle. So it's just going to tell you how close it is to that x-axis. So let's turn to the back. It says find the reference angle if theta equals, and it gives you 3 problems. Okay. If we're going to find the reference angle, let's say of 170 degrees, this is going to be, let me erase this. Didn't work. There we go. 170 degrees is going to start on the x-axis and go all the way over here. Okay, it's going to be close to this 180. So if we want to find our reference angle here, we're going to take 180 degrees minus 170. So our reference angle would be 10 degrees. You would take 180 minus 170. Okay, let's try B. Let me erase this too. On part B, we have 205 degrees. Okay, so that is going to be past 180. So it's going to go, and then end up at 205, wherever that is. I'm just guessing. So if you want to find your reference angle, it's going to be, the closest axis would be this negative. Okay, so we want to take this angle minus 180 degrees. So 25 degrees. Your reference angle will always be positive. If you get a negative angle, like let's say you did 180 minus 205, you did it backwards. Okay, you would get negative 25 degrees. Okay, so if you do get a negative, just take the positive. You still get the same answer, it's just that you did it backwards. So if it helps you to remember it just one way, like if it's in quadrant, I don't know, 2 and 3. So if it's in quadrant 2 or 3, you would always subtract 180. If that helps to do it the same every time, you can. And then just always make it positive. Whatever helps you guys. I like to draw the angle, see where I'm at, and then find the closest x-axis. It makes more sense to me that way. All right. Ooh, I don't know what it is. Last one. Last one, we have 310 degrees. So it's going to start on this x-axis and go all the way to 310. So our closest x-axis to this terminal side would be this one, right? That would give you your reference angle. So we would do 360 degrees, because that's what this x-axis is. 360 degrees minus 310. So my reference angle would be 50 degrees. On your worksheet, you're going to have one that is in quadrant 1 also. So let's say, and this isn't on your paper, but let's say you have a 70-degree angle. Okay, if you want to find the reference angle, the closest x-axis would be this positive one. All right, so you would do 70 minus 0, which is 70. So if you have an angle in the first quadrant, that is your reference angle. It's always going to be, like the front of your note said, it's an acute angle, so it's always going to be less than 90 degrees. If you get an angle that's greater than 90, you did something wrong. You subtracted by the wrong number. So that's a good way to check. If you get an angle greater than 90, go back and check what you subtracted by to get that reference angle. All right, number 3, we're going to draw the angle and find the reference angle if theta equals, and it has 5 problems. These are in radians. Okay, so you're going to have to know where 2 pi over 3 is. So 2 pi over 3, I don't know the easiest way to do this. If you want to draw your unit circle and label the radians, that will definitely help. Or since we're talking about thirds, from 0 to pi, it would be 1, 2 thirds. I don't know if that helps or not. Because you have to think of this graph instead of like a bunch of different sections, only think about it in 3 if we're talking about thirds. I don't know if that helps or not. I always like to draw the whole circle, but I'm a little OCD, so y'all may not want to do that. The other way you could do it, like I said, you can figure out if it helps to figure out the decimal. 0.67 is going to be greater than half pi, right? But less than a whole pi. So you could do it that way. But 2/3 pi is going to be in that second quadrant. So the closest x-axis is going to be the -1. So we're going from the terminal side to the next x-axis. So we're going to do pi minus 2/3 pi. My reference angle would be pi over 3. Go ahead and leave your answer in terms of pi. Okay. So if you want to use your calculator, you're going to do 1 minus 2/3. It'll give you 1/3. You just add the pi at the end. Okay, so let's try another one. The next one is 4 pi over 3. Okay, so 4 pi over 3, like I said, I don't know how y'all want to do it. There's a lot